Limit as x goes to 0, the square root of x plus 1 minus 1 over x. First thing we're going to do is plug in a 0 for each of the x's. That will give us the square root of 0 plus 1 minus 1 over 0. 0 plus 1 is a 1 minus 1 over 0. Square root of 1 is a 1 minus 1 over 0. 1 minus 1 is a 0, so we have the 0 over 0 indeterminate form. We will have to rework this. Since we have a root combination, which is a root involving the variable x in some way, added or subtracted together with at least one other term. That's happening here in the numerator. We're going to be able to use the root conjugate method. We're going to multiply the numerator and denominator by the root conjugate. So we have limit as x goes to 0 of the square root of x plus 1 minus 1 over x. And we're going to multiply this by the conjugate of the root, which is the same terms in the root combination, but opposite sign between them. So it'll be a plus sign between the two terms of the root combination. And we're going to put this in the numerator and denominator so that we're multiplying by a form of 1. We're not changing the value just to look. Now when you do this, you're going to FOIL out only the root conjugate pair. That's in the numerator here. The first, root x plus 1, times root x plus 1 will just be x plus 1. The outside will be a root x plus 1 times a positive 1. That'll be plus root x plus 1. The inside will be a negative 1 times the root x plus 1. That'll be negative root x plus 1. And last will be negative 1 times a positive 1, which is a negative 1. Now the outside and inside terms will always be able to cancel, opposite sign, same value of each other. And it turns out here we're able to cancel the plus 1 and the minus 1 as well. So let's go ahead and do that. Now all this will be over the denominator, which is not a root conjugate pair. We will not want to FOIL or distribute or anything. At this point we now have changed it to a different type of problem. It's no longer a root conjugate problem, but it has become power functions. And we have 0 over 0 still, but we have the factor that's making the 0 apparent in the numerator and denominator both. It's actually the x. When x goes to 0, what makes the 0 in the numerator and denominator is the x. We can cancel those x's out, leaving us with a 1 in the numerator. We should no longer have the 0 over 0 indeterminate form, and we can plug a 0 in for the remaining x's. That will give us 1 over the square root of 0 plus 1 plus 1, which is 1 over the square root of 1 plus 1. The square root of 1 is a 1, 1 over 1 plus 1, which results in a 1 over 2.